That's what software-defined promises, right? Essentially, bringing the infrastructure awareness into the applications, which is a kind of a scary thought, perhaps, to some, but it's definitely where it's all going. So just a little bit about SIOS. SIOS, we actually the sponsors of this conference, so I hope you're having a good time and learning a lot and having fun. And we also are the sponsors of the sort of extension of this conference in Raleigh and in Columbia, South Carolina. SIOS, actually, there are different variations of what it abbreviated and translated to, but SIOS is actually one of them. Is SIOS stands for Software is Open Source, so we're definitely in the right place here. It's been founded in 1999. And it's owned by a Japanese company called SIOS Technology Inc. in Tokyo. We actually publicly traded in Japanese stock market with their worldwide offices in US, UK, and Japan, and now also South Korea and China, with over 50,000 licenses installed, of what I'm going to tell you in a minute. And we have a number of, obviously, partners that we're working with. So what we actually do at SIOS is, today at least, is high availability solutions, clustering and data replication solutions for Linux and Windows that support, obviously, and protect services in virtual and cloud and physical environments. So if you do actually happen to look for a solution in this space, please feel free to visit our website or perhaps see me after my presentation. So now I'm going to jump right into my presentation. And I know that I'm actually standing between you guys and a beer. That's actually going to start serving soon. So I'm going to try to keep it short and interesting, perhaps stir up some conversations while you guys are going to enjoy GitHub Drink Up. So first, let me kind of lay down the landscape of what's actually been happening and what's happening right now, right? So as you know, there is obviously this big cloud trend that's happening. And what's interesting about it is not only the fact that obviously it promises and brings kind of the cost effectiveness of the IT or reduction of such, but also it brings a new business model, right? And that business model is switching from where the infrastructure is being owned by the companies to where it's being rented, right? Which brings additional challenges to the technology, where essentially the technology have to figure out ways to actually provide the infrastructure for the time it's being rented and guarantee the service levels for that time that's being rented to the particular consumer, right? The other aspect is, of course, the big data. To some, it's obviously a lot of data that's rapidly growing, but also it brings, once again, challenges to the IT with the fact that obviously it brings new applications like Hadoop and such that are distributed, completely new and different workloads that are essentially require flexibility and agility at the IT side, on the IT side to be addressed. So while those business models are kind of pushing on the technology answers are. One of them is a software-defined anything, right? And as I mentioned, the software-defined anything, that's actually software-defined networking, software-defined storage, where essentially the control plane is extracted from the data plane, where the data plane, again, is left to the commodity hardware. And the control plane provides ability for perhaps centralized analytics or centralized management orchestration of those services that are being delivered, right? And truly, as at one time the Mark Andreessen written "Why Software is Eating the World," that's what we're actually seeing as part of this trend, right? Where essentially, besides the fact that we're extracting the control plane from the hardware, if you think about all other businesses that are actually driving today and with this trend, like for example UPS, right? Their business is not about actually trucks, but about the efficiency of their software that provides perhaps a more efficient path to the drivers and provides the ability to track your packages and things like that. And similar to Amazon, right? It's not really about the infrastructure. It's about the services that they provide. So again, once with the software defined, the hardware essentially commoditization aspect has been talked about for a long time, and now it's actually feels like it's going to happen. But also, what's interesting, both of those actually create the convergence, and the convergence that we observe are, first of all, we actually start seeing new kind of appliances that are being created, right, where this network can converge with compute, right, storage can converge with compute, right? So those kind of convergences start happening. Also, you see convergence happening in the IT management side, where essentially cloud that brings essentially a single view into your infrastructure that today being managed by multiple organizations at times, right? By splitting down them into storage and network and compute and application as silos, is now managed through a single pane of glass. And I guess my favorite example is actually I worked with one of our customers in Amazon space who were trying to move some of the workloads, and I had I think it was 5 people on the phone with me. One of them was responsible for security, one of them was responsible for network configuration, for storage, for application, for the actual operating system, right? And they were all looking at the same the same screen, right? While it could be just one person doing this. So this convergence is very interesting to observe, and until you actually see those examples, it's just you may not actually see them until it's actually it happens, right? So what is the core of this, and what is the foundation that's necessary to actually make all this possible? I guess one thing, it could be those very nice and shiny polished knobs, right? The knobs, by knobs I mean you have storage knobs, you have network knobs, you have virtualization, you have stack over stack over stack, or is it something else, right? So while we're going to park this thought for a minute, and we're going to go into actually what the customer's problems are today. So the customer problems is, how do I build a data center with all the things that are emerging that are basically flexible and agile, right? While the solutions, by the way, you guys are seeing what I'm seeing, right? Yeah. But while the solutions that are traditionally being implemented in IT are, pretty expensive, because traditionally there's a certain number of vendors are involved there, right? The software is closed, the black box solutions, and they're pretty expensive, right? And also, obviously, there is a growing amount of data, which I referenced earlier, dispersed infrastructures, geographically and such. And how do we handle all that while we can still maintain, or at least reduce, which is also always a goal, right, the capital and operational expenses? So it seems like the answer becomes pretty obvious, right? Well, virtualization and cloud, right? Light bulb. It existed today. It's been around for a while. It's got to be there. It's got to be able to help us, right? So we have this happy guy. We have a happy customer who actually says, I think I know the solution, right? So now we're going to put this aside, and let's look at actually what's happening in data centers today in terms of the infrastructure, right? So you have a storage, kind of a storage tier, those silos that I talked about. You have a storage tier where you have EMCs and Dells and NetApps and IBMs and HPs and such. You have network with Cisco, Juniper, and traditional vendors that you've been seeing for a while. And you have cloud and virtualization vendors, right? While those solutions also provide scale and capacity, they mature, they're strong. Those are proprietary solutions. They're not heterogeneous, which means they basically lock you into their particular vendor, and they are expensive, right? And when you look at the growing amount of data, it's kind of hard to neglect the fact that it's hard to spend that millions of dollars on the SAN when perhaps there are alternatives to this, right? So the alternatives that we start seeing that coming out in open source space and open foundation space is actually answers all 3 tiers, right? In the storage space, you obviously have a Ceph, we have Hadoop, we have SwiftStack, we have GlusterFS and OrangeFS. And by the way, what's great about this conference, you're actually going to see, I mean, it seems like everyone mentioned in this slide are actually here, and you can actually talk to them and hear them speak. Actually, Orange FS, I think, is actually presented right now. So in case if you're here, you probably won't be able to hear them. But in the network stack, we have also this emerging list of vendors, including the Open Daylight, which is essentially an initiative under Linux Foundation that drives this kind of like a standardized way, or sort of, you can say, a standardized controller for the networks. Right? And actually, the chair and the CTO, Brocade, as same person, will be presenting on this tomorrow, which we can learn more about. And of course, in the cloud virtualization stack, we have OpenStack and Eucalyptus and Cloud Stack. So what's particular about those solutions is because they also have scale, right? However, they are open solutions. They are heterogeneous, and they are cost-effective, and they do not have vendor lock-in. So now let's dive into each particular one. And by the way, many may say like, well, I mean, and we hear that a lot too, or at least I do, where sure, I mean, but EMCs and IBMs and those guys have been there for a long time, right? But it's amazing that actually, when I was actually talking to some of the CIOs not too long ago, that organizations who, I mean, when I was in IT years ago, we were able to only afford about one POC in 6 months, because to be able to POC a new product, it takes time. It's very time intensive, and it takes you off what you were supposed to do in the first place, right? Now they're actually doing 10, 15 POCs in 6 months. And then my question was like, wow, you guys, I guess, have more resources or something. Well, no, because they're trying to understand what alternatives they can find that addresses the cost, the flexibility, and agility, right? So I think it also becomes very obvious that people become more, I guess, open to other alternatives other than what's been traditionally provided or sold to them, I guess. So now looking at again, the cloud and virtualization, obviously those guys are software defined by default or from the beginning. And actually, you can say that they actually kind of created this whole trend in the first place. Right? They said, well, you know what, with OpenStack or Cloud Stack, we're going to deliver you a data center just like Google. You will be able to, like, pop the instances in and out, but the difficulty was that actually underneath, you have this rigid infrastructure that doesn't provide you that capability. It's very difficult to maintain it or make it very agile. And of course, you have all this kind of like stories about IT shadowing, where essentially your employees or your enterprise or your company go and put things in Dropboxes and such, because simply you are not fast enough to implement things, right? So the OpenStack was kind of this initiative to create such data centers, but however, the infrastructure underneath was not ready. And that's kind of was a big push for software-defined to start appearing. And also, you can see that other vendors like EMC and IBM start contributing to that. There's certainly not all the APIs are available, but to the extent where you can provision things, it's kind of for a lot of things already there. Storage, what's interesting about storage, and I'll talk about perhaps Ceph in particular, is obviously distributed storage devices are different from SAN, because with SANs you actually rate your data across the disks, and here you actually rate your data across the servers, eliminating the single point of failure and essentially bringing your locus of management to a centralized location. And they all have different type of unique factors to them that essentially make them differentiating from each other. And I know there was a question that was asked earlier about the different file systems. Well, I know that, for example, Ceph in particular different from each one of them, because actually, besides providing the object store, it also provides a block device. So you can actually attach it as an SCSI device, which not every other one does, or not, I guess, natively, right? Of course, the software-defined networking aspect of it was recently, well, not too recently, but maybe two or so years ago. I mean, it's been around actually for a long time, but with the acquisition of Nicira for somewhat like several $1 billion or close, actually it opened everybody's eyes saying, oh, what happened? Why those guys got bought by VMware for so much? And I guess it's going to be a big difference and going to be a big push for SDN. So what is SDN? It's actually, it provides a centralized management of the network infrastructure for things like, again, orchestration, automation, and analytics, which is kind of like true for any software-defined kind of trend that's coming out. The reason why it's interesting is because it makes, first of all, I'll actually switch it back. I would say that it makes networks cool again. Because I worked on networking infrastructures for a long time. And to be honest with you, to make anything highly available with these rigid networks as they are today, it's quite a challenge. Obviously you have all these different layers of VLANs and such that were introduced, but to be able to simply fail over a machine from one data center to another, or even from between the subnet, you have to actually provision everything in advance. But how can you make it more flexible? And obviously there are answers to this. Guys like Amazon, obviously they don't have people running around with cables and serial ports to configure VLANs, right? It's all provisioned through the APIs. So that's what the software-defined network is bringing, right? It makes networks not suck anymore, It brings the scale, and of course it brings the efficiency in terms of operations, and finally it provides ability for applications to tap into those resources, and again, perhaps auto-provision themselves in the future. Again, a scary thought for IT, but it is coming. That's why I think this kind of merger between IT and application development is kind of needed, which once again brings to the convergence, right, that I talked about earlier. Also, what we have, so the software-defined in itself, basically, it essentially was pushed to provide ability to deliver IT as a service, right? So as any resource, you can think of networking, you can think of like compute, such as the CPU and memory and storage, to be delivered to the consumers as a service, and of course make applications more aware of the infrastructure underneath. Right? But the interesting thought on this whole software-defined aspect, that over time, if you think about it, as the infrastructure starts developing APIs with the software-defined concept coming out today, right? And applications kind of start absorbing those APIs and under-provision them, that over time, the software-defined networking will get absorbed by the infrastructure, and that concept will no longer exist anymore, right? Over time. So does it mean it's dead? Well, it's not entirely. Like I said, it will be part of just next generation of networking, or next generation of application and compute. So what is going to be the next trend? Well, anyone know what this is? Yeah, so the Google Barge, there was a lot of speculation. What is it, like a Google Glass facility for, I guess, for demonstrations? But it's been confirmed by multiple sources that it's actually a floating data center. And it provides, essentially, it floats between the locations to provide extra compute power to where it's needed. So is it like a next generation of hardware-defined stuff? Have we just made the full circle again, right? It becomes kind of interesting, but it's very valid that basically universities, for a while already, kind of dropped the software-defined where it came from in the beginning, and now working on the next generation of APIs to make hardware more flexible, to be able to clock down your CPU cycles to make it more efficient and things like that, to make it more agile. But to be honest with you, even though the software-defined is still going on and will be going on for a while, also one of the challenges with software-defined is the fact that you always, as a consumer, you're always looking for some hardware you can put it on. And today, it's kind of tough to find just to take an OpenDaylight controller and perhaps big switches operating system and just drop it on a white box, right? Because it's kind of hard to find that box in itself. So where do you buy it? That's why it was inevitable that there will be emerging vendors like Cumulus Networks partnering with Medakura, for example, to make that happen. So it will be cheaper. Yes, it will be running on white boxes, but somebody actually has to provide it, right? So now, with this aspect, and by the way, this whole barge, somehow it needs to float and figure out where to float. So once again, it becomes a giant knob, right? So who controls that knob? So now we're going back to the guy who was happy and he found that the cloud is the answer, right? Or virtualization, so to speak. So is that truly the answer, right? Well, not entirely, because if you think about it, when virtualization came out, it came out with a set of unanswered questions and concerns that still haven't been addressed by IT. And we talked to many of our customers today that basically trying to figure out still how to solve it. Right, so the promise of the virtualization was to provide ability for multiple VMs to live on a single piece of hardware, and it's there, right? But the thing is, if you look at it, the many customers still pretty much 80% under provision their data centers. And actually VMware and have tools that actually will tell you that you're 80% under provision, but how do you solve that? Right? So what are we doing wrong? Or maybe perhaps when we don't understand something, maybe we cannot measure that to be able to understand it better. Right? So with virtualization, it came this whole concept of I/O blender, where you have multiple resources fighting for the data store that sits on the same LAN. You have the whole noisy neighbor concept. You have the VM ballooning. You have all kinds of things like basically all the kinds of problems that were created by virtualization. But it's tough to track them. Tough to track them. What didn't help is also the cloud came out, and you have all these kind of things like private cloud, hybrid cloud, public cloud, and how do you deal with all these things when you still haven't been able to figure out the first problem in the first place? Of course, the technology moves on, right? So VMware right now, for example, introduces yet another tier of storage called vSAN, right? So it's yet another kind of abstraction layer over all infrastructure. Great technology, right? Provides you better agility, provides you ability to provision things. But again, you haven't solved the first problem. Where is my bottleneck, right? So obviously, the fact that you have APIs today available and operating open solutions today even provide them more openly because they've simply been providing them from the scratch. But obviously, like I said, the closed vendors also provide those solutions. Well, all you have is, once again, a set of knobs, right, that are available for controlling, right, individually. Some of them control more than the others, so you kind of have a stack war. So OpenStack can control VMware and Hyper-V, but at the same, and they can be controlled individually. You have a set of open source and closed source monitoring tools. But the problem with those monitoring tools is also they're looking at things very, very flat, right? They only look at networking. They only look at, let's say, compute. They even can do things like tell you when you're going to run out of space. So they do some intelligent forecasting into the future to tell you, based on regression, where you're going to end up out of space, for example, right? But the biggest problem still remains that there is no hierarchy into that view. There is no way to actually bring the application and the way it runs all the way down to the perhaps LAN that it sits on and what happens in the between and pinpoint where the bottleneck is. And in fact, we actually hear many of our customers who are cloud providers, they're saying that we have three-tier support system, but all the calls end up on the third tier because neither the first or the second can answer the question what the problem is. It's a huge problem for them, so clearly the problem has been solved. Well, did the virtualization fail? I would say no. I mean, anything that's coming out, you have to have a core infrastructure to be able to provide things. But you still need more to be able to actually make it, to realize what the value of that virtualization is, truly. So what you need is actually a brain. That's what you're missing. And I'm not saying that human brain is not enough. I'm just saying that it's just impossible when you have 35,000 VMs, realistically, to understand what each particular workload does and to realize how to configure it and maybe resize it or maybe expand it or maybe shut it down or maybe it needs to be deleted in the first place because, like I said, somebody was running a large Hadoop cluster test and left it because this, the consultant left. And you have this thing running, and you just simply don't know about it out of this noise of 35,000 VMs that you have in your data center. So again, you have tools today, which is on the left side, that provide you monitoring and even forecasting. But really, you need to be more predictive about what you're doing. IT basically is looking for a solution that will say, like, here's what you need to do, and here's why you need to do it, because I know, based on the trends and based on the historical trends that I obtained, here's your waste, and you need to delete those. Here's the workload that you're running. And by the way, that workload can be, the hardware or the perhaps virtual machine that you're running on can be significantly reduced because you oversized it. Oh, and by the way, comparing this workload to every other workload in other deployments that we have, 80% of the people run it on 2 CPUs versus 6 like you have provision. So it's probably a good opportunity for you to optimize that, right? So what we believe at SIOS is that this is kind of unsolved problem, and we keep hearing about it. And we come in from availability space, right? But as we were looking at availability space, and we kind of realized that availability is just a subset of what defines a service level, right? So to deliver a service level, availability is not enough. To deliver a service level, you also need to deliver performance. You also need to deliver the efficiency of the infrastructure. So that's why we realized that there is an opportunity for us to actually expand the vision of availability and start building the solutions that actually address the consistency of the service level delivery in the data centers for our customers. So we actually working on this project called Semantic I/O, which basically breaks the silos with the innovation between the compute storage and network, right? And like you said, you may say, well, I've heard this monitoring stuff, right? But again, this is not about monitoring. It's about providing you the answer, the insight into what's happening. And there are many tools that that exist today that provide you ability to, in libraries, in open source, that provide you ability to actually do the machine learning aspects. There are many of them we heard today about, right? But as one of the presentation mentioned, what we need now is the vertical aspect. So one of the verticals here is IT, which cannot be neglected, because there are some unanswered questions, and there is some nuggets that kind of still there or haven't been discovered that IT is looking for to optimize how the infrastructure is being managed and consumed. So what we really want to produce is actually, with Semantic I/O, is a product that will be, the Google Now of your data center, or for the, for the Apple users, the Siri of your data center, where that will basically create leveraging the machine learning technique, will provide ability to essentially to provide information to the IT administrator and tell them not only when are you going to run out of space. Certainly, there will be overlap with the monitoring tools because it's kind of unavoidable. But specifically, where are those bottlenecks, and how to optimize specifically your environment. So just to give you a hint, and we actually right now in the process of building this solution, which we're actually going to contribute to the community to help us to steer up and support it, is kind of a purposely high-level architecture of what we're building. So starting from the bottom, obviously you have those knobs, as I mentioned, that basically provide a lot of information. Besides information, which is statistical information, also provides the capability to understand the object model, the relationships, and potentially even provision them, right? So that's a great opportunity for us to partner with the community to provide us ability to build those providers into different stacks that exist today. Those providers talk to the analytics engine through the message-oriented middleware. And what it makes this solution is very distributed, an opportunity to grow to basically unlimited, right? And on the top, what you have is obviously the traditional object model that you can consume from those different knobs that exposed at the bottom. The operational management, such as this is the opportunity for us not only to recommend, but act on the recommendations. And also provide ability, which is on the right side, leveraging the machine learning techniques that already exist today, because there's nothing have to be invented. As we mentioned today, there are many libraries out there. All we need to do is just apply those libraries to and our expertise that we get from our experience working in IT and with IT and cloud providers and our customers, applied to the analytics engine to be able to slice and dice information in order to provide that insight into the bottlenecks and recommendations in terms of how you can better structure and how you better maintain and run your environment. So at the top, you have the security layer and the API. Once again, it's a public API that will be exposed as part of the solution and can be consumed by perhaps other packages, by other platforms, and integrate with such. Also, besides the fact that the whole thing is open source, there's the opportunity for the community to provide enhancements into our analytic engine to see what other insight we can obtain from the data, from those data stores and LANs and storage and networks and things, to provide more insight through the API to the consumers of it. So what we're working on is actually going to come out in the third quarter of 2013, and we're actually going to have it available on GitHub, and hopefully it will come to the data centers in IT organization and perhaps one of yours. So to find out more as we actually rolling this out, please feel free to visit our website and follow me, because I'll be talking about it quite a bit once we go full speed into it. So you have any questions? Doesn't sound too crazy? Or okay, yes, go ahead.
So no plans for making it available for AWS?
Yeah, yes. Yeah, we actually, currently we're starting with the biggest market that we believe there is opportunity, which is VMware. But we're definitely planning to tackle AWS and Hyper-V and potentially other environments as well. And to be honest with you, that's one of the things that we believe that community can provide support with, is to actually, once they find this solution to be attractive and addressing the needs and finding those nuggets in the infrastructure where they can optimize, we believe the community will help us to, to make the solution more powerful. Yes?
When you say community, do you mean open source or?
Yes, I meant open source, yeah. And to be honest with you, I mean, some people, well, it's kind of, I also heard some question, well, machine learning, seriously, you're going to open source that? But to be honest with you, I worked in analytics for a long time. I was actually one of the people who was running Sphinx natural language processing. And it was driven by the community, and it was very successful. So I wouldn't, I guess, I'm not saying that you are, but I'm just saying that there were some comments where there was some underestimation of what community can provide. Clearly, Hadoop is a community-driven project as well. So yeah, that's what we were looking for, to input not only just the actual, I guess, adoption to those knobs, but also the scientific part of it as well.
And when will the first version of that be available for people to look at?
Well, basically, we're shooting for the third quarter of this year. But right now, we feel that's appropriate to actually, and in events like this, to broadcast the message, to see, because to be honest with you, there are no solutions that we are aware of that address that today. And that's a great opportunity for the community to tackle this problem and make it possible. Because again, virtualization is there. All the core stuff is there. There are many tools that do all kinds of monitoring, but to actually retrieve that nugget and provide the input, that's what we're after, really. So, any other questions? By the way, speaking of the fact that we, if anyone interested, we actually also are looking for developers. So if you're a developer and interested in an opportunity, please stop by and we'll talk. Perhaps get you information. Anything else? All right. Well, thank you for your time. I hope it was interesting to you and informational.